Hi everybody, in this example we would like to consider about twisting moment or torsion. We have the same length of cylinder. The cylinder itself is different, the cross section is different. On the left side you have inside is full of cylinder, solid one, full. And this one right side, this one, in this case we have the so-called hollow cylinder. Inside is empty. We often use this kind of structure for transmitting torsional moment because we can minimize the required materials. When you consider torsion characteristics, here we have very robust structure when you use this kind of inside is empty cylinder, hollow shaft. Because when you consider this value, when you consider shear modulus with elasticity and IP, polar moment of inertia. Polar moment of inertia is in normal case 5/32, the potential 4. The 4. That's why it's mainly dependent upon the size or shape of the. Actually, change of angle phi equals GIP TL. Or when you consider maximum shear stress IP TL, when you apply this formula, then you can easily get final answer. Okay, we have steel shaft here. And both steel shafts. One is inside is full, another one is hollow one. Solid one and hollow one. We would like to transmitting torque. This IC is 1,200 Newton meter. And allowable shear stress is 40 megapascal. And normally shear stress is given by material itself, its material's characteristics. And shear modulus of elasticity is same. It's also dependent upon material itself. And here also we have some requirement: maximum allowable change of angle, which is expressed in meters, degree over meter, then is also given. In this case, we would like to know required diameter on the left side, and required diameter D2. Okay. In this example, how we can properly apply the formula. We have two possibilities. One is given by this requirement, and another one is given by this requirement, maximum allowable shear stress. Okay, we can apply both change of angle or maximum shear stress. Okay, firstly let's consider left side, solid one, and phi equals G, shear modulus of elasticity, IP, and TR, not TR, TL, sorry, TL. Okay, here this value T is given by torque, let's say Newton meter. L is let's say we don't know L. Instead of that, if L is divided by here, let's say L, just at this moment, G is given by 78 gigapascal exponential 9 gigapascal Newton per meter squared. And IP is what? IP equals 5 over 32, which one? Diameter, D0, exponential 4. And 5 over 32, the outside 4, exponential 4. Then we can, when you see this formula, we can calculate phi over L. This one is what? Theta maximum is given by, when I write down it again, 1200 Newton meter and 78 multiplied by 10 exponential 9 Newton per meter squared, and 5 over 32 D4. This one is given 0.75 degree per meter. And this degree, that's why we normally use radian. That's why it should be converted. And normally 100 or 360 degree is 2 phi. Then you can convert to radian value. Then we have this relationship, then everything is known, and finally you can calculate the O. Okay, that's the for the case of when you apply this condition, 0.775 degree in meter. And next one, when you apply this formula, tau max is what? Here 40 megapascal, exponential 6 megapascal Newton per meter squared, equals T is transmitting 1000 Newton meter, and it is multiplied by radius R. R is we don't know. Let's say T outside divided by 2, and IP if all calculated 5 over 32 D4. Then on the left side we know that, on the right side we can delete something, and finally you can find the O as well. We can find this value, and we have another value. One is this one, by this condition. Another one is when you apply maximum shear stress, then we have two different one. And here as well, what's the maximum value? That's the worst one, larger one, you can take it. And next one, in this case, same process, but what's different? This one is different. IP value is different. IP, polar moment of inertia, equals 5 over 32 in this case. Outside diameter D2 4 exponential 4 minus inside diameter, of course just the D1 is what? D2 minus this value, this thickness is D2 over 10. And when you calculate the D1 value, we have another, and this one is multiplied by 2. Okay, then we can say this was 5, 1 and 4 D2, and we can substitute here 4 over 5 D2. Okay, 4. Then we can calculate the IP for hollow one. In this case as well, we can apply same condition, theta max condition. This one is phi over L, GIP T. When you apply this value, then you calculate GH value here. G is known, then torque is given. Then you can calculate theta max. Theta max is given, then IP value is given by this process, D2, then you can calculate D2. Another one also, tau max equals TR IP. When you apply this condition again, then you can also find D2. When you compare both of them, which was obtained by with different process, then you can compare both of them. Finally, you can decide the worst one, larger one. You can take one. Okay, that's the example 2. Okay, in this example, you can apply this one and tau max this relationship. And key point is to find which one is worst one, which is worst one. Then you can compare both of them. Then finally you can decide, you can select one of them. In the case of hollow shaft, to find polar moment of inertia is like this one, which was given like this one. Then if you know polar moment of inertia, then finally you can apply same condition. This one and this one is given, then you can find the two value as well. Okay, that's for example 3.2. Okay, thank you for your attention.